It has finally come time to document the latest little toy. It is a clock that runs on a T-Display S3, and it will throw up backgrounds and then write the time and date, battery voltage, and when you press one of the buttons, it adjusts the brightness. I find 28 works really good. It was hard to read the digits on some backgrounds, so they're either too light or they had too many colors or both. So I ended up putting an outline around the numbers, not on the voltage as you can see, but on the time and date. Also, you can pick any color you like for the time, date, and battery voltage, and also you can pick any color you like for the outline color. So red seems to work good. I use red. It surely makes a difference. I think when you push this, the outline goes away, so you can see the difference right there. I took the outline away for speed because I was having a little trouble. I was using, in fact, I am still using OFR. That's font renderer. What's the first word? OFR. It's a library. Open Font Render. I'm using OFR for the voltage and brightness field, but I switched to TTF for the other two. I just didn't have the time. It was taking over 600 milliseconds to update time and date when I was using OFR, so I switched back to TFT ESPI library and using the drawstring rather than OFR rendering. So that's a little toy. Let's talk about the code. Oh, one more thing while we're got the close-up here. If you press both buttons, which is hard to do while holding the phone, it goes into menuing, and as you use the bottom button, it'll cycle through, and you can, let's say we want to toggle all fields. There's all the fields gone, and you just get to see the background picture. Well, let's go back and turn them back on. The top button implements, and if you're sitting here, if you're sitting here for more than 15 seconds, it will automatically return to the clock. You can also get this from the serial monitor, which I'll show a little later. There's one additional field on the serial monitor, which you don't have here, which you don't need here, so I didn't put it here. Make sense? I hope so. Oh, let's look at code. There we go. This was originally from an Instructable. You can see there, Instructables.com T-Display S3 NTV clock. Started there, but it is wildly different now. And you can also see where the code is up on GitHub. T-Display S3 clock with backgrounds. And right now there are 196 backgrounds, and the SPIFs area, which is what little FS uses, which is what I'm using, has room for another 200. So I may load up more as time goes along. So there's the two things. Commercial use is excluded by the original author, and I agree with that. If you want to use it for commercial purposes, let me know. And let him know too. Okay, so let's move on and look at this a little bit. Oh, we can look over here while we're here. You can see where it's running and the startup stuff. Can I zoom this a little bit? Yeah. So we initialize little fs. If it's not formatted, we'll format it. Then we go count the JPG files in little fs. You can see there I got a 10 meg little fs partition, only about half used. Then I go load up a table And the table is going to have the name of the background and the colors used for the time, date, battery voltage, and outlining. Hopefully the numbers there will match 196, plus there are 3 digital, very simple digital graphics that can come up. May add some more of those someday. They just take code space, not little FS space. They're just code commands that draw some graphics. Connect to the WAP, wait for time, load up the brightness. Oh yeah, I didn't show that. Then here's the menu from the serial monitor. Has the same ones except we have enter a P, upper or lowercase, to show the name of the current background picture loaded. That's in case you want to go change the colors in the source if the colors aren't looking right. Then we get our time sync. Once a day is enough. Set the brightness and load a picture. And right now this code is set to change the picture every 10 minutes. Easily changed if you don't like it. Okay, let's look one more time at the display, and if you hit the up button, that increases the brightness. You can see there. If you hold it, it steps, and it steps faster the longer you hold it. And it remembers whatever your setting is. Every 10 minutes it looks at the current brightness, and if it's different, it saves it. It's an hour by hour save, and it'll do the same brightness for the same hour tomorrow, and ever and ever, ever and ever. Just like Cinderella lives happily forever after. Well, you're not going to sit there? Of course you're not. Okay, let's look at the code a little bit. Don't know what's really interesting here. There's Open Font Render, which I couldn't remember the name of a while ago. I also have some fonts stored. The background picture is loaded up by JPEG decoder, so you'll need that. You'll need a little FS, and then some required settings. There's some notes there. All the sprite sizes are set. There's all the sprites I use. Now I use sprites so I can get invisible, so you can see the background picture through the characters. Very nice feature of TFTE SPI library. We go initialize a little FS. We go count the files. Set up the pins. If you set the orientation different, the pins change. So the top pin is always increased brightness and the bottom pin is always decreased brightness. And it also changes the menu activation pins. In boards version 3, the LEDC business changes a little bit. You used to assign a PWM timer. Now that's done automatically, so you don't have to do it. I believe it's the 0 here. Yeah, and you attach a pin to the timer, so the 0 timer. Now he assigns the timer himself. This 8 is the bit level, the 5000 is how often the PWM waveform is repeated, 5,000 times a second. So then we create the sprites, set the battery mode. Now the battery mode is kind of weird. There is no turn off completely for the battery. The only difference is the battery either does or does not send current to the display. When it doesn't send current to the display, the unit draws about 70 milliamps. When it is sending it, it draws about 90 milliamps. So obviously the display takes about 20 milliamps. At least at level 28 it does. I don't know a lot higher. So then we connect to Wi-Fi, standard stuff, set up the pin modes. and initialize the JPEG decoder, and finally set the screen to black and get ready for whatever's coming. Get down to the loop. Now there's some things that we want to do repeatedly, and one of those is watch for the button presses. So they're right up here at the top. Dude, stay focused. Thank you. They're right up here at the top, looking for all the presses. Want to get the current time, and then we're going to check buttons too for brightness change and menu calling. Then we're going to say if the second hasn't changed, that's enough for now. We don't need to do all this other stuff. We'll just go away. But if we're going to hang around, there's the return to get out. If we're going to hang around, we'll save options. That means actually check to save. We only save them every 10 minutes. Then the callback for time sets this Boolean. If it's set, we put out this message. Sometimes it takes a long time to get that message. I don't know why, but the time's right. So I don't care. I probably should just take that out because it's not very useful. So then we set the hour brightness on an hour change. On a minute, if it's a minute, we get a new picture. And then build and show is where all the action happens. And then that's it. This little thing here is to show how long a loop takes to run each time, either every first 5 seconds or once every 20 minutes, once every hour, I mean, on the 20 minute. And that's all of that. Pretty simple, huh? JPEG utilities, not much there. Well, not much now. It was a sure mess to get it going. Here's the table where we fill in the color for the B is the battery color, T is for time, O is the outline, and D is the date field. So each of those get their own color. There's also a background hatching feature that's available. And that'll draw a little dark box between the time and date text and the background picture. So in case it's really too bright to read, you can darken it a little bit so it's easier to read. The outlining really almost took away the need for that. So not really useful so much anymore. The backgrounding was suggested by a person on Facebook, and I really appreciate him doing it. I don't have his name right now. So it works, so most of the hatching is set to false now. User defines your kind of standard stuff. Joe is a friend of mine. We share this code. So if it's for him, then we have a different SSID and password. Now, wake up and sleep is when the display is turned off by default. If you override that, then it won't happen. But by default, it shuts off the display at 10 p.m. Wakes it up at 10 a.m. and shuts it off at 11 p.m. or 2300. Here's how often it changes a picture. That's in minutes. And when you press brightness change button, after you stop pressing, it'll stay around for 3,000 milliseconds. And then this is for me, it's a different WAP and password. Here's your orientation, either power on the left or power on the right, because this only works in landscape. And it's not optional, it's on the left here after recompile. Minimum brightness 0, of course. And the menu hide time, as I said, if you don't press the button in the menu, it'll go away after 15 seconds. There's the 15 seconds in milliseconds. Utilities is where the picture colors are set on the graphics. sprites are filled in, build and show calls that routine. Then here's the outlining. There doesn't seem to be any actual outlining available in any library. So I had to do it myself, and the way I did it is you move the string. You prepare the string right here with the S-print-F. Then you move the string back and forth, first diagonal, up left, up right, bottom left, bottom right. Then you go left, right, up and down, orthogonal. I had to do the orthogonal before the diagonal, or it left a hole here and there, which I didn't quite understand, but I reversed them, and then no more hole. Then you set the color, draw the real thing, which has now been encased with the background, the outline. So you put this right in the middle of all of that. And then you push it, and this color says this is going to be the invisible color. And since black is your background color up here, this black becomes invisible, so you can see the background through the numbers. Same thing with, here's that, when you turn off the show fields in the menuing, this is what turns it off. Then same thing for the other one, you S-print-F to get the day of the week and the month and all that stuff. Do the same thing for the outlining. Draw the real thing. Then the battery level is what also is the brightness, and it uses OFR, open font render. I probably should change it. I may. It takes too long. I probably get another 25 milliseconds back, so that's why I haven't done it. It's not a lot. The menuing is here. You can look at how the buttons work. The highlights are when you press a button, you wait 50 milliseconds, and then see if it's still pressed. And then when you're done with what you're doing, here's where you put up all the menu stuff. When you're done with what you're doing, you want to be sure to wait for unpress. You don't want to run off while somebody's still got the button pressed, because it could do something you don't want to do. So somewhere down here is wait for unpress. I don't see it right now, but you can find it. Get the current time, naturally, just getting current time. Hour dance, I invert the display 4 times to show the hours since there's no speaker. Setting the hour brightness, this is saved in with the preferences library by the hour. Save the option, same thing. Edit time, standard stuff. Here's that callback. It sets that Boolean. It's not a bool, is it? Maybe it's an integer. Then the 3 silly graphics. It just draws some lines on the screen. It ends to a kind of a black area in the middle of the screen. 3 of them, one for red, green, and blue. Then here's the little menu that shows up over here. And that, I don't believe that's used anymore. That'll probably come out. Then the standard stuff over here. This is aerial rounded, is used for the battery voltage and the brightness notification. Then the other fonts, Britannic bold. There it is. 66 for the time and 36 for the date. And that's pretty much it. So that's the code. As you can see over here, when he loads up something, he says. Now, if we want to see there we go. If we want to see P for picture, show me the name of the picture. He shows it down here somewhere. Unknown input. Did not type a P. There it is. I didn't type P. Picture showing, he gives you the name of the picture. And he also gives you brightness level now. Then he repeats this so you know what to type. That's also comes out right up here at the top. Just to remind you, here it is. Just to remind you what you can type. And the others are the same. Battery usage level, either full or partial, that's with or without display. You can't turn it off. If it's there, it's going to be used up. If it isn't plugged in, there's no option. F for the fields, turn them on or off. P we just did. B, battery voltage, you can turn that off separately from the others. Because if you don't have a battery in there, it's kind of stupid. That field will still show the brightness, but it doesn't show the battery voltage, the useless battery voltage. Now let's move on to a couple of other things here. Here's the little create the font thing. Where is it? There it is. Let's bring this down a little bit. And you type in the number of the font, which is immediately ignored. Then you type in the name of the font, which must match, and then he appends either TTF or OTF down here. They don't say that. This acts like it should be, because he talks about the size for spiffs is 31. It seems like what you're giving here is the name that's going to go into spiffs, but no, it's not, and it's not documented. It's the actual name of the font, which means he ignores this number, so why have it? I don't know. This is the create font, and it is in this library. Make this a little bigger so you can see it. It's in the Arduino, or whatever you call it. This is the sketch folder, libraries, TFT, ECPI. I almost said it, didn't I? Tools, create smooth, create font, and then it's create font PDE. And you have to load up the processing application, which is such a generic name, it's kind of hard to find, but I think it's processing.org is where you find it. So that's how to make the fonts. Oh, and you specify, of course, your font size and points. And here is the magic. This little file is called partitions.csv. It's not really a CSV. It is in form, but not in function. These are column specific. I accidentally moved this like that to make it match, make the M's match and make them out right, and then it ignored it. So it's not a CSV. It's got to be right there. It cannot be moved. You can either have 0x and an actual number out here, hex, hexadecimal of course, or you can have M. This could say 0x 10,000, or it could say 10K, capital K. I'm sure they wouldn't accept a little k since they don't even understand CSV format. So that's what controls. That gives me a 3 meg partition and a 10 meg data. I've got about 3 meg unused here. As you can see, this is blank, and he is smart enough to take this, add that, and end up with that. Then take whatever that is and add that and end up here. This is the start address for the partition, and this is the size of the partition, of course. Now, one other, where are we? Here we are. Windows. Windows has introduced a new bug. It won't let you do what you want to do. So you got to do that. Then if you look in the data, you'll find all the pictures. Lots and lots of pictures, 196 of them. They're all 320 by 170. There's even more that are hiding down there. I made up all these, grabbed them from free backgrounds on the web, mostly. That one I really like. There's some of them that look really good, some of them that look really not so good. Butterflies is difficult because it's so bright. It's hard to get something that'll text that'll read there. Cherry blossoms, also marshmallows is a difficult one. But you can play with it, do what you want, change them. And I believe that's all. I always forget something when I'm through here. Oh, here's a really pretty one. Squirrels. Yeah, of course it's not going to sit there, is it? I forgot to blue tack it down. That one looks good. And I believe that's it. Let me take one more quick look here. Yeah, we saw that. Saw that. We saw that. And the only other thing, there's the GitHub. I'll put that in the comment section. And there's all the files. There's the pictures. Some notes about installing. It's a little bit of a messy thing to install, but it's all detailed in the README. About 12 steps in there to get it all going. None of them are hard. It's just things you have to do. And be sure to not remove or change partitioned CSV, or it will cause a lot of trouble. And that's it. I hope you enjoy the product. It's not a product. I'm not selling it. The app. If you have problems, please let me know. I don't mind hearing about problems, and I sure love to hear about additions that can be put into it. Although I think this one's about full, I will still entertain problems or requests for additional stuff. That's it for me, Mikey the Midnight Coder. We'll see you later.